Good morning dear learner, I am Dr. Poddar, faculty of Bhila Institute of Technology, Durg. I welcomes you all. Today in this lecture session, we will see brief review of microwave communication. Microwave communication, this title has two words, microwave and communication. At first, we will see what it is mean by the word microwave. This word is again combination of two words, that is micro and wave. Let us understand this. Remember, electromagnetic microwaves are extremely very high frequency signal, but still called microwaves. Why? Because wavelength of these waves are very small. Now, here another term introduced, that is signal. Remember, signal means energy which has information, and what it is mean by information we will see a bit later. Now, this EM electromagnetic microwaves are very high frequency signal, and remember, high frequencies are highly dangerous for human beings. We should be very careful while using such microwave devices, for example, mobile phones, microwave ovens, etc. For example, if there is a leakage in the microwave, then that is very dangerous for the persons who are working in the kitchen using microwave oven. And talking in mobile phone for very longer duration without headphone is again a very dangerous. So, whenever you have to talk for a longer duration, it is recommended that you must use headphones. And another thing, that residing near the towers, so that is again a very dangerous for human being. So, we should be very careful while we are dealing with the microwaves. Now, to understand what is the difference between a wave and a wavelength. So, let us first try to understand what it is mean by a wave. A wave is a disturbance or a variation that travels through space and matter in a regular oscillating fashion. A wave is any disturbance that transmits energy through matter or empty space. In terms of physics, waves are formed by the disturbance in a medium. Wave transfer energy from one point to another point without transferring the mass. Let us understand this with the example. In case of water, waves are produced when one put his or her finger or any other object on the surface of water. These waves are transverse wave. They spread out from the point disturbance it created at. This is due to the travelling of energy from that point outward. Then in case of air, the disturbance is created when somebody want to talks. When a human being want to talks, right, his or her vocal cord starts vibrating. This vibrations of vocal cord creates disturbance in the surrounding airs of the mouth. By their movement, this transferring the energy through air. These are sound waves and they are longitudinal waves. Then the some examples of wave, let us see. One is water wave. Water waves are transverse wave that travel on the surface of water. They are caused by disturbance such as wind, current and earthquake. Another is sound wave. Sound waves are longitudinal waves that travel through air and other media. They are caused by vibrations of object such as vocal cord and guitar strings. Another is light wave. Light waves are transverse wave that travel through space at the speed of light. They are produced by atoms and molecules when they are excited. Another is seismic wave. Seismic waves are longitudinal and transverse waves that travel through the earth's crust. They are caused by earthquakes and volcanic eruption. Then most important, our electromagnetic waves. Electromagnetic waves are transverse waves that can travel through space and matter. The types of electromagnetic wave includes the radio waves, our microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays and gamma rays. So, what are the examples of waves? Water waves, sound wave, light waves, seismic waves and our EM waves. So, microwaves are EM waves, that we will remember. Then let us try to understand what it is mean by wavelength. To understand wavelength, we need to understand that imagine there is in front of you a sine wave picture is there, right. In this case, what you can do, you have a pen and paper with you and just draw a sine wave on that paper, and then the way I am explaining, you try to mention that points. So, it will clear your idea more. The highest surface part of the wave is called crest and the lowest part is called trough. So, you just draw a sine wave, mention there 2 points at the top and at the bottom and call that as crest and trough. You just make 3-4 cycles and mention these 3-4 crest and troughs. The vertical distance between the crest and trough is the wave height. So, now you mention in your figure what is the wave height, that the distance between vertical distance between crest and trough, and remember the 1/2 of the wave height is our amplitude. So, now you understand the term amplitude also. And then second, the horizontal distance between two adjacent crest or troughs is known as wavelength. So, you draw just figure and mention all this point crest and trough and wave height and amplitude and wavelength, just for the sake of practice, for better understanding this concept. The de Broglie's relations about the wavelength is, the wavelength is described by a symbol lambda and the relation becomes lambda equal to h small h by small m v, where h is Planck's constant, small m is the mass of the particle and v is the velocity. Every particle has wave nature as well, but it is only truly evident when a particle is very light, such as our electron, whose mass is extremely very less. That is, the mass of an electron is approximately 9 into 10 to the power minus 28 grams. Then from Einstein's equation, we understand the energy of a photon, that is designated by a capital E, that is equal to h f. Again h is the Planck's constant and f is the frequency of the photon. Now, we will remember electromagnetic waves never travel as a single wave. For our understanding and theoretical analysis purpose, we draw pure sine and cosine wave, but practically there is no pure sine and cosine wave. So, wave EM wave never travels as a single, they always travel in the form of group, and this group of wave is called modes. And the best way to represent the group of wave is our AM envelope, amplitude modulation envelope. And we will remember that there are 4 real modes that are exist. They are transverse electric mode, that is called as TE mode, then transverse magnetic mode, that is called TM mode, and two hybrid modes, they are HE and EH. So, this way we have the 4 modes. So, remember what is mode? Mode means the group of waves, and wave always exist in the form of group, and the group of waves is called modes, and there are 4 real modes TE, TM, HE and EH. And the best way to represent the group of wave, that is mode, is AM envelope. Just for the sake of practice, you may draw on a paper how the AM envelope looks. Now, with this we will try to understand what it is mean by the microwave term. Now, we are coming to the second term of our title. Our title was microwave communication. We try to understand what it is mean by the microwave. Now, we will try to understand what it is mean by the term communication. Now, what it is mean by the communication? Communication means the exchange of information, right. Then what it is mean by information? Now, information can be either audio, can be either video, or third type of information is data. So, let us first understand what it is mean by audio. Audio means audible. Audible means listenable and talkable. That means a human being can able to listen and talk, right. So, that audio frequency range is which a human being can able to hear and talk is 20 hertz to 20 kilohertz. Now, point is that from where we got the knowledge of this range, which is 20 hertz to 20 kilohertz. So, remember the knowledge of this audio frequency range, we got it from the acoustics. Now, again the question is what is acoustics? So, just remember that acoustics is the branch of physics which deals with the sound signal, same as the cryogenics. Cryogenics is again the branch of physics which deals with the signals at very low temperature, which is required in our satellite technology. The way electronics, electronics again a branch of physics in which we control the flow of electrons, nowadays mainly in semiconductor for the purpose of instrumentation, computation, that is computer, and communication. So, this way we will remember that acoustics, cryogenics and electronics are the branches of physics. In acoustics, this branch deals with the sound signal, cryogenics deals with the signals at very low temperature, and electronics, in this branch we control the flow of electron in semiconductor for these 3 reasons: instrumentation, communication and computation, of which communication we are discussing in this lecture session. So, this is the first type of information, that is audio form. Then second form of information is video. In video, all the picture and scenes, that type of information comes in the video category. Now, how we decides the bandwidth of the video signal, right. So, pictures can be black and white, pictures can be color. So, a standard size of picture, what is the smallest element of picture? That is called pixel. So, picture is made up of pixels. Now, take example of black and white picture, right. The variation in black and white picture, that is from black to white, and the zero variation means a complete picture can be completely black or completely white. So, the bandwidth lowest range will be 0 hertz, and for highest range, that the case when the one pixel is black and one pixel is white. right. What is pixel? Pixel is the smallest element of the picture, right. So, if one pixel is white and one pixel is black, right, in this way if the complete picture is formed. So, what is the example of such a picture in our universe where one pixel is black and one pixel is white? So, chessboard pattern, here one pixel is white and one pixel is black, right. What is pixel? Pixel is the smallest element of the picture. So, if we take this chessboard pattern and we convert this chessboard pattern into electrical signal and we observe the frequency. So, that comes as 5 megahertz approximately. So, the bandwidth of the video signal that ranges from 0 hertz to 5 megahertz, and this way it is find out. So, this is about the second type of information, that is video. Then coming to the third type of information is called data. So, everything type of information, everything that is neither video nor audio, that comes under the category of data. Especially in our mobile communication technology, when we move from third generation to fourth generation, right, where the technology PSTN, that was in third generation public switch telephone network, changes to PSTN, that is packet switch telephone network. So, public to packet, that change is there from third generation to fourth generation, and in fourth generation all the information, the type of information is converted to data. So, in fourth generation onwards in mobile communication, information means what? Information means data. You are using mobile communication, every month you are recharging your mobile. So, what type of recharge you are doing? That is data pack. So, why data? Because in fourth generation onwards all the information is converted to data and a packet switch telephone network technology is used. So, this way we will remember what is the term communication means. Communication means exchange of information. Information means either audio or video or data. From mobile communication point of view, from fourth generation onward mobiles, information means data, that we will remember. So, well learners, we understood what is microwave communication. Now, we will move ahead with this title itself, that is microwave communication. Now, from the history point of view, in 1888, Heinrich Hertz became the first to demonstrate the existence of such waves by building an apparatus that produced and detected microwave in ultra high frequency region. So, Heinrich Hertz is the, we may call, the father of the microwave communication. Now, if you try to understand the types of microwave communication. So, microwaves are two types. So, microwave transmissions are terrestrial microwave transmission and satellite communication. Terrestrial microwave transmission are sent between two microwave stations on the earth itself, right, and it is the most common form of long distance communication. Microwaves are defined as electromagnetic radiation with a frequency ranging between 300 to 300 gigahertz. In contrast, the wavelength ranges from 1 mm to around 30 centimeter. Microwave radiation is commonly referred to as microwaves. They fall between infrared and radio waves in electromagnetic spectrum as such. So, if you look at to the electromagnetic spectrum, the microwave lies between infrared and the radio waves. Microwave is a form of electromagnetic radiation with the wavelength shorter than other radio waves, but longer than infrared waves. Its wavelength ranges about 1 meter to 1 millimeter, corresponding to the frequencies between 300 megahertz to 300 gigahertz. Roughly or broadly, this range is taken. Microwave communication refers to the transmission of information using electromagnetic wave with wavelength in microwave frequency range. Typically, that ranges from 1 gigahertz to 30 gigahertz. This method of communication is widely used for various applications due to its ability to transmit data over long distance with high bandwidth. Because of such a high frequency, microwave communication can able to offer high bandwidth. Of course, this bandwidth compared to optical communication is very less, but other wireless communication, this microwave communication is offering very high bandwidth. Now, let us try to understand the characteristics of microwave communication. First thing is that because of their high operating frequency, microwave systems can carry larger quantities of the information. The way we say that microwave communication offers high bandwidth, so they can carry more information. High frequency means short wavelength, which requires relatively small antenna. So, this is another characteristics of microwave, as because they are very high frequency or shorter wavelength. So, the size of antenna is small. Third thing, microwave signals are more easily propagated around physical obstacle such as water and high mountains. So, terrain obstacles, the microwave can deal much better in the terrain obstacles. Especially in our satellite communication, we say that the remote areas are accessed by the satellite communication, where the fiber optic cable installation is not possible. Then the pro side or the dominant side of the microwave communication are, as we know that microwave communication supports larger bandwidth, hence more information is transmitted, that is true, and for this reason microwaves are used for point to point communication. Due to this high frequency, more antenna gain is possible, and due to this high frequency, higher data rates are transmitted. Why? Because bandwidth the microwave communication provide is high or more. Let us see in detail high frequency and bandwidth. Microwaves communication operates at frequency typically ranges between 1 gigahertz to 30 gigahertz. See, such a high frequency, right. That is why microwave communication allows a very high data rates and provides large bandwidth, which supports the transmission of a vast amount of data, including voice, video and internet services. And practically today all of us are using mobile communication and all of us are using this thing. So, this is very true that vast amount of data, including voice, video and internet services, microwave communication is providing. Microwave communication is a line of sight transmission, right. It requires a clear line of sight between the transmitting and receiving antenna. Signals can be obstructed by physical barriers such as building, tree and hills. So, line of sight between transmit antenna and receive antenna is very crucial in microwave communication. This one should remember. That is why the importance of directional antennas are very crucial. Microwave communication utilizes highly directional antennas like parabolic dishes and horn antenna to focus the microwave beams. Directional transmission reduces interference and enhances signal strength over long distances. Then let us understand microwave propagation as a plane wave. Microwave propagation involves the transmission of electromagnetic wave at microwave frequency that ranges from 1 gigahertz to 30 gigahertz. When discussing microwave propagation, it is very important to consider or understand that microwaves are plane waves, right, under certain condition. Why? Because this simplifies the analysis and understanding of how microwave travels through space. These plane waves are a special case of waves where a physical quantity such as phase is constant over a plane that is perpendicular to the direction of wave travel. Just like periodic wave, plane waves have a wavelength, frequency and wave speed. Then how we deal mathematically or theoretically with the plane wave? As we can note, a wave of amplitude A, and consider this as a capital A, wave number small k, angular frequency omega, phase angle phi, propagating in the positive x direction is represented by the following wave function psi of x of t, that is equal to a dot cos of k x minus omega t plus phi. This is how mathematically the plane wave represented. In physics, the wave front of a time varying wave field is a set of all points having the same phase. Set of all points having the same phase. The term is generally meaningful only for field that at each point vary sinusoidally in time with a single temporal frequency. Wave fronts usually move with time. Now, understand what is uniform wave front. In plane wave, the wave front means the surfaces of constant phase, right. So, in plane wave, the wave fronts are infinite planes that parallel to each other. The electric field that is designated by capital E and the magnetic field designated by capital H are perpendicular to the direction of propagation and to each other, forming a transverse wave. Direction of propagation: the wave propagate in single well defined direction. The field E and H are uniform in any plane perpendicular to the direction of propagation. About phase and amplitude: the phase of the wave is constant across any plane perpendicular to the direction of propagation, and the amplitude of the electric and magnetic field does not vary with the position in the plane orthogonal to the direction of travel. Now, with this I want to conclude this session on the brief review of microwave communication. Considering microwave as a plane wave is a powerful simplification that is valid under far field condition and in homogeneous lossless media. This perspective adds in the theoretical and practical analysis of microwave propagation, facilitating advancement in microwave communication technologies. Microwave communication remains a crucial technology in modern communication system, offering high capacity and reliable transmission over a long distance despite challenges like line of sight requirement and weather sensitivity. Ongoing technological advancement continue to improve its efficiency and application scope. I hope you have learned a brief about the microwave communication in detail. So, thanks for patient listening.